So hello everybody, my name is Margot, and today I'm going to present ordinalClust, which is our package jointly developed with Julien Jacques and Christophe Bernacchi. So first I'm going to introduce. Oh yeah, should I just go? Oh, I can't move. Okay, that's okay. Okay, so first I'm going to introduce you what are ordinal data, what ordinal data are. Then I'm going to introduce the Bose distribution, which is a recent distribution for ordinal data. Then I'll present what co-clustering is, which is one of the features of my package. And I show you how we can use the package in an application in oncology. Then I'll conclude my talk. So, first of all, what is an ordinal variable? So, a variable x is said to be ordinal when it's categorical, and the levels have an order among them. So, for example, if I ask you what's the color of your eyes, and the choices are green, blue, or black, it's the same if I ask you if they are black, blue, or green, because the order is not important. However, if I ask you how was your day today, and the choices are it's very good, or it's not too bad, or it's awful, there is an order in the response, you know? So that's what ordinal data are. And so you can find this kind of data in marketing survey, for example, when you have to rate a product or a service you are given. So in ordinalClust, we provide function to classify, cluster, and co-cluster ordinal data. So in this talk, I assume that most of you were familiar with classifying and clustering tasks. So I'm going to present a bit more of co-clustering. But now I'm going to present the Bose distribution, which is distribution we rely on in this package. So it's a very recent distribution from 2016, I think. And basically it has two parameters. So you have the position, mu, which is basically the mode of your distribution, okay? And then you also have the pi parameter, which is called I can't remember how it's called. Precision. Yeah, the precision. Yeah, it's called the precision. It's between 0 and 1, and it's going to indicate how scattered is your data around the mode. Okay. So you can see it like a variance. It's not mathematically, it's nothing to do with variance, but it's going to indicate how scattered is your data around the mode. So yeah, these two parameters are very interpretable. When I gave you these two parameters, you can have a precise idea of what the shape of your distribution. Okay, so now I'm going to talk about co-clustering. So basically, when you have an original data set, okay, yeah. When you have a matrix of ordinal data with n lines and j columns, for example, what co-clustering does is simultaneously clustering the lines and the columns. Okay, so you have clusters of your observations and clusters of your features. And we call the crossing of row cluster and the column cluster a block. Okay. So that's the more formal notation. So we have an X matrix with n lines, j columns, and we have G clusters in line, H clusters in columns, and we also have a matrix V, which is going to indicate for each row to which column, to which row cluster it belongs, and W is going to indicate for each column J to which column cluster it belongs. Okay. So, okay, as I said, the crossing between the J row cluster and the H column cluster is called a block. And something mathematically, something a bit maybe less important to understand for the whole talk, is that we have V and W independent, okay? And we have an assumption which says that an element xij, when I know the partition, so when I know in which block it is, they are all independent. So basically what it says is that when I know I'm in this block, for example, I know that all the elements are sampled from the same distribution. So in the Bose distribution case, I know that all my elements here are sampled from a Bose distribution with mu and pi, which are the same in this block. Okay. So the mu and pi is going to be different in each block. Okay. Okay. So to infer this model, what do I need? So I would like for each block to have the mu and pi, so the parameters, and I also need to have the size of my clusters, so the size of my row clusters and column clusters, which are gamma and rho. Okay, and I also want to know V and W, which indicates for each row to which row cluster it belongs. Okay. And this kind of configuration is typical for a NIM algorithm, so expectation maximization algorithm. But in this case, I won't go into details, but in this case, it's not possible to use the EM algorithm. So I'm just using an extension of it, which is called the SEM-Gibbs algorithm. The S is for stochastic. Okay. So now we have a rough idea of how to do co-clustering with ordinal data. So we have the Bose distribution and then the assumption I just talked about. And what about clustering and classification? Well, here we see clustering and classification mathematically a bit like extension of the co-clustering, like easier cases of co-clustering. So for example, in clustering, I don't know my V partition, but I don't know the WK partition because I don't want to cluster the columns. Okay? So I just have to estimate V and theta, which are my whole parameters for each block and the size of my clusters. Okay? In classification, theoretically, it's easier because I do not need V because in my training set I already know to which cluster, so to which class it belongs for each observation, and I don't want to cluster the columns neither. So I just have to estimate the parameters theta. Yes? Okay. So now I'm going to show you how we use the ordinalClust package on an application in oncology. So this is my original data. And this is the data call dataset, which is in the package. And so I have patients. In line, I have patients that are female with breast cancer, with breast tumor, and they respond to questionnaires. Okay, so to questions. So in lines, I have patients. In column, I have the questions. And the shades of gray are going to be the levels of the ordinal data, and the whiter the cell is, the more positive, in the more positive way was answered the question, okay? Okay, so that's the data I have in the data call dataset, and when I see this data, when I plot this data, it's hard to have a good idea of what's happening here, because I can see a bit of black here, so I know that these questions were responded in a more negative way, but I don't have a great idea of what's happening. So with the ordinalClust package, I can do clustering, co-clustering to know what's happening in my data, and these are the main arguments. So X is my data set, M is the number of levels for the questions, and for now, I'm just going to do a clustering, and I just need KR, which is the number of row clusters. Okay. So to perform a clustering, I need the BoseClust function. Okay, so here I just want, for example, 3 clustering in line, and the other arguments are not important for now. Okay, so when I perform my clustering with three clusters, that's what I get. So now I have a better idea of what is happening in my dataset, because I can see a group of patients, a cluster of patients that responded in a more negative way. Then here, a cluster of of people that answered in a more positive way, and this one is in between, I would say. Okay. So so that's okay, but it's a bit simple to say, okay, they are the negative person, the positive ones, and the in between. And so if you want to have a thinner, refined analysis of your dataset, you can perform a co-clustering, okay, of your data. So when I perform a co-clustering, I can use the both-co-clust function. So now I have to provide the KC argument, which is the number of column cluster, and I still have my number of row cluster. Okay, so I can see that I still have my negative cluster in lines, my positive cluster, and the in between. But I also have a better idea of what's happening among the questions. So, for example, for these questions here are responding in a more negative way. Okay, a bit more. So I can get a look to this question and see what's happening. So see what's going on here. Okay, because even the in-between group is answering a bit negatively in this question. So that's co-clustering is a way to have a better refined analysis of your data. Okay. So I think I'm going. Okay. So in classification, well, when in the data called classif dataset, which is in the air package, I have a variable which indicates if the patient passed away or not. So I can use this data to train a model and have and be able to predict the disease or not of the person. So for that, I can use the both classif function of the package, and when I said earlier then I didn't need to cluster the variables, I lied, because we realized that when we clustered the variables, we would be able to have a better accuracy in our results. Okay, so in this package you can use a classification method without clustering the variables, and you can also decide to cluster your variables, and you can have better results with that. Okay. Okay. So I'm going to conclude. Okay, you have a full documentation on HAL. So it's the French archive. This documentation now is not updated, so I need a couple of days to update it. Then I didn't talk about it, but the package is able to take into account variables that do not have the same number of levels M. Okay, and okay, the models I talked about are applicable to mixed type data. So we are working on another package called useClust, and you can see it be available soon on Chrome. Okay, thank you for your attention.
So thank you for the talk. Questions, comments? Yes.
Is there any function in your package that decide how I take the variables kr and kc, so the number of clusters I want, or should I know the numbers of clusters before?
Okay. We have a criterion which is called ICL. Okay, and so you have to perform the clustering before with different number of clusters and then maximize this criterion. But we are working on a method to automatically do that.
Behind one.
I don't hear you. Sorry.
If you repeat your clustering on the same data, would you get the same results, or there are some randomness? Because with many of these methods, if you repeat your analysis, you would get a different sets of clusters.
Oh, you mean reproducibility?
Yeah.
Yes. Okay. So yes, it's stochastic, and well, it depends a lot on the initialization. Okay. So yes, I can have different results with the same data set and the same arguments. But if I mean, technically speaking, if I set the seed, I will have the same results. But yeah, it's an algorithm, like mathematically speaking, it's an algorithm that can get different solution.
As I understand it, you characterize each block by the Bose distribution with parameters mu and pi. Is it of interest to use those as summaries for the block, and also to compute some measure of the homogeneity of the individual cells about that?
So about the summary, yes, I should have talked about that because I just visually summarized my data set in the talk. But yes, if I see the parameters, as I said in the Bose distribution part, they are pretty interpretable. Like if I see the parameters, I'm able to know what's happening in my block. Okay. So and the second question was about like a homogeneity. Yes, we don't know how to do that with these parameters because they are a bit special. So it's not very easy to have a kind of distance or in my blocks. But I could use classical methods, but I don't have a new one with my parameters, mu and pi.
Presentation. Do you think that you can add some sparsity constraint with your co-clustering in order to be more robust?
I didn't hear well. I think you're speaking about missing values? Sparsity?
Values, but just to add some sparsity lasso constraint in order to make some selection, like a method proposed by Witten with co-clustering.
Okay. Sparsity, but sparsity is when you have in your matrix a lot of response or a lot of cells that have the same value. Is that your question? So I could have like blocks of noise, for example. Is it your question?
It was just there are a lot of sparse approach with co-clustering, but it was to know if you propose to do the same with your approach, but we can speak together.
Yes. I don't know. I didn't think about it. Sorry.